grade 12. So this is a video lesson for the corrections ka activity 4. Before we start the corrections, basically ndifuna nje ukusummarize into endiyiqapheleyo that you are asking. Whenever we have substituents, the name of the organic molecule, it will start with a substituent or substituents, ne? Where you are mentioning their position, the position of those substituents and the name of those substituents. If ever there's more than one, you go alphabetically, ne? And then second part of the name, ihamba nge-root, sathi root name okanye stem name. This is where you mention the prefix or the prefix here to indicate in number of C atoms. So basically, this is where you're going to have your meth, your eth, your bute, pent, hex, hept, oct. That's where you are indicating the number of the carbons in the main continuous chain. So my parallel part in the main continuous chain, another space of a chain. So that's where you mention. And then you mention the suffix. The suffix is going to indicate a homologous series. Series to which the organic molecule belongs to. For example, for alkanes, we end with ane. For alkenes, we end with E, Ne, where you start with the position and then with Ene. If you take alkyne, YNE, then you mention, you first mention the position. Let me just make an example. I'm not going to draw this. When's the example? Say, for example, methyl, substitute 2-methyl propane. So, that's the part, lena part, le. Then, le, part, lo prop, le, your root name. Then, le part, this part, similar colors. This part is going to be this one. It's the suffix. Whenever you have a branched hydrocarbon, this is how you're going to name it all the time. So let's go to corrections. Remembering to follow the rules for naming organic compounds. So if ever you can't follow here, because I'm not going to explain the rules again, I'll just paraphrase. If ever you struggle to follow, you can use as a rules page 132 usiyavula, rule 1 to rule 6, I think. Yeah, I'm going to paraphrase them, to summarize them. So here 1.1 we have an alkane. How do I know that it's alkane? Because we have propane upper and there's no halogen here. There's only an alkyl group. So this is an alkane. And then as I said, there's a what? There is this part, substituent. And then there is a what? There's this part, which is the root name, indicating total number of carbons in the main continuous chain. And then there is this part that indicates the homologous series to which this organic molecule belongs to. So when we write structural formula, say there should be 3 carbons in the main continuous chain. So let me go and draw this molecule. It is a 2-methyl propane. So when I draw it, I'm going to do this. That's 1, 2, 3 carbons in the main continuous chain. And then there is a methyl where at carbon 2. So if I number from here 1, 2, 3, even if I number back and forth, people, it's going to be 1, 2, 3. It will be the middle carbon. So because it is the middle carbon, I am just going to place a methyl group phakathi middle carbon. Whether ndiyibeke phezulu okanye ndiyibeke ezantsi, it doesn't matter, ne people, as long as it's carbon 2. So CH3. I'm just using different colors so that you are able to note that methyl. Then you place the hydrogens. 2-methyl propane, yearly. Then we go to 1.2. Again, now I'm going to move a little bit faster. So 1.2, I'll have to keep coming back and forth. When it is this complicated molecule, I always start on the root name. That the root name, it hex. That means that I must have 6 carbons in the main continuous chain. And the suffix there ends with A and E. Therefore, it is going to be an alkane. I mean to say there are single bonds between carbon atoms. It can't be an alkane because there are halogens here. Yeah, so this is an alkyl halide. So what I'm going to do is I'm going to start with that hex and place 6 hydrogens. I mean 6 carbons in the main continuous chain. So that's going to be, that's 1, 2, 3, 4, 5, 6. And then I choose, but I'm going to start ubala from left to right, or I'm going to start ubala from right to left, because I'm the one who's drawing this molecule. So most of the time, given that I choose left to right, because intuitively, that's bala from left to right. So I will choose to make this my carbon 1, 2, 3, 4, 5, 6. I will leave the numbering only because since I enunciate copy corrections. Otherwise, you don't have to number when you are writing this in a test or in an exam. So let's go to the molecule. It is 2.3.3 trifluoro, yeah? And notice 2 of those fluorines, they are placed in the same carbon. 3.3. That means they are in the same carbon. So carbon 3 2. Then the third fluorine is placed on carbon 2. So it's out. Where is it now? It's out. Okay, I place fluorine here. People. And then I place the other 2 here. There are my fluorines. And then go back to the molecule. The other part, it 4-methyl. Therefore, I go and place methyl carbon 4. Up or down, doesn't matter. And I like to leave space again. Zinganqubani hydrogen zako. Otherwise, it won't be neat. Your work won't be neat. So, yeah. Doesn't matter length of bond. So, after that, I place my hydrogens. So that each carbon has a stable octet structure where it has 8 valence electrons. There it is. So 2.3.3 ndoni trifluoro cause 3 1 2 3 4 methyl hexane. And then Say 1.3. 1.3, I want green. 1.3. So if I go to 1.3, trifluoromethane, very easy. Methane, kumbula. There's one carbon, methyl, one carbon. Ane, alkane, but haloalkane because there are halogens there. So trifluoromethane is one of the easiest to draw. I just draw one carbon, and then I place 3 chlorine atoms. 1, 2, 3. It doesn't matter, it could have been here, the other chlorine, just that happens to be my preference at the moment. So it trifluoromethane, 3 trichloromethane, man. So it's 3 chlorine atoms in a 1 carbon structure. And then see 1.4. 1.4 kuthiwa but 1 ion. So if but 1 ion, you have now. So it's going to be 4 carbons, but 4, 1, 2, 3, 4. But power ion, YNE. So that means it belongs under the homologous series alkynes. So I can place a triple bond upper. That's going to make this 1, 2, 3, 4. Carbon 1. Or if I want, I can place that triple bond this side. That's going to make this carbon 1, 2, 3, 4. Either way, I am correct. Now all that I need to do is to make sure that each carbon has a stable octet structure. So the first carbon has 1, 2, 3 bonds. So I'm adding the 4th bond and balance it by placing a hydrogen pair. And then the middle one, carbon 2, I cannot place a carbon there. I cannot place a hydrogen there. Why? Because it already has a stable octet structure. That's 1, 2, 3, 4 bonds around it. So already it has a stable octet structure. I cannot place another one. So I go to carbon 3. Carbon 3, stable octet structure, 1, 2, 3, 4. And then this is my last one. Yeah, but 1 ion, that is it. Ne? The next one I'm going to write next to them because there's space there. So next question 2, identify the homologous series to which the following structures of functional group belong to. So let's start with 2.1. So 2.1, if you look at it, obvious that it has a double bond between 2 carbon atoms. That is an alkene. Let me emphasize, these are structures of functional groups, people. They are not organic molecules. Rather, we are generalized that all alkenes have a double bond between carbon atoms. Yeah? So it's more of a way of generalizer. Remembering that a functional group will determine the physical and the chemical properties. Physical, such things as color, texture. Chemical, such things as boiling point, melting point. All of those things, the way they react, the speed at which they react, all of those things will be influenced by the functional groups. So alkene, the other one is an alkane. Why? Because there are single bonds between carbon atoms. And then this one is a alkyl halide. Okanye is a haloalkane. Then the fourth one, this one, is an alkyne because alkynes have a triple bond between carbon atoms. So you need to be able to recognize and be able to draw structures of functional groups. And when you draw a structure of functional groups, do not place hydrogens here, because the moment you place hydrogens here, now you are not saying all alkenes. Now you are saying specific ethene. So never ever place hydrogens when you draw a structure of a functional group. So before that, let me just mark this. So you will be able to see where the corrections are. So let's go to the other question. So write down the general formula of the homologous series identified with 2.3 and 2.4. 2.3 and 2.4. So if we look at 2.3, that is an alkane. I mean to say haloalkane. Haloalkanes, bani C. Let me go write it down there. 2.3. So that's. Let me go. I'm keep forgetting now. It was question 3. So 3. Then university for 2.3. For 2.3, it be haloalkane, so it's going to be CnH2n minus or plus 1 X standing for whatever halogen is present in the haloalkane molecule. And then for 2.4. 2.4, I know now I check it is an alkyne. The alkyne sitting CnH2n minus 2. Yeah. So it's a but CU4. U4. Okay, I know that would define the term homologous series. Do not make a mistake of like swapping the definitions between homologous series no functional group. A functional group, a group of atoms, or an atom or a type of bond that determines the physical and chemical properties of an organic molecule. Now, if you have different functional groups, what does that mean? You are different homologous series, because a homologous series is a different. I mean to say, it is a group of organic compounds that have the same functional group and are defined by the same general formula. So let me go and write it there. A group of organic compounds that have the same functional group and are defined by the same general formula. I'm well aware that pi notes and have the same general formula. It's fine. English. It's fine. Seku 5. Question 5. Kutwa. Let me leave it. I'm going to name the organic molecule there next to it, because this will be much more easier. So to name the following organic molecule, let me just move it a little bit so that, yeah, let me paste it here. Okay, name the following organic molecule. Yeah. Name the following organic molecule. So in order to name it, I just need a different color. In order for us to name it, kuthiwa phayana, if you remember kweza rules, identify the functional group. Besithi rule 1. Then rule 2, ebesithi ba when you number, identify the longest continuous chain containing the functional group. So basically we have 1, 2, 3 functional groups. However, ukirule ngabhalwanga phayana ethi ba i-double bond, it must take priority over, I think ibibhalwe, I don't know, I'm going to check. You must prioritize the double bond over its subsequents, because remember halogens also count as subsequents. So if ever there's a double bond or triple bond, qala prioritize yona. So basically beko rule 3 othi number such that the functional group lay priority in this case, it must occupy the lowest number possible. Then rule 4, if kukho intoni imethyl, I mean to say i-branch funeka ugqibele ngo-Y, L. So nasi branch yethu apha izaba yile. So 1, 2 izaba ngu-ethyl. So sine-ethyl apha. We have an ethyl. And then rule 4 uthi ba if ever une-substituent a-halogen, ziname uthi bromo okanye so i-bromo le. Bromo uthini uthi fluoro ne. Then rule yokugqibela u6 ithi ba if you have multiple substituents, in this case we have multiple substituents, uthi ba basically hamba alphabetically when you name organic molecule. So for example u-B, so qala ngaye uyaba number 1 u-B, then mangathi number 1 u-B, let me just use A, saqala ngaye alphabetically, people say zenze alphabets. B saqala ngo-B ne, and then size ngo-E because sithi E, F, E size ngale, then sizothi F when we name ne. And then we get to, remember igama lethu line subsequent, and then libe ne root name. After that libe la part yokugqibela i-suffix le include i-homologous series or include i-position ye-double bond. So when I name up and out, alphabetically qala, I am going to say, okay, let me just number so to make things easy. So this is carbon 1, 2, 3, 4, 5, 6. Again, I am starting this side because of that double bond. It takes priority over the subsequents, even if those subsequents are halogens. So when I name, I'm going to say now i-UB, besiqala ngo-B, so I'm going to say 4 bromo ne, and then ndize phi kubani ku-E ndithi 2 ndithini ethyl. If ever ukhona umuntu ongayivanga lento, the reason sithi ethyl is because I can't say 1, 2 upper, because the longest continuous chain must contain the functional group. It has to, the functional group, the double bond has to be part of that longest chain. Actually, identify the longest continuous chain. The longest continuous chain containing the functional group. Check rule 2 ku page 132 phako siyavula. And then ndithi ke ngoku ndigqibele ngofluoro ndithi 5 fluoro. When I check ba i-root name yami izothini, there are 6 carbons in the main continuous chain, so I'm going to say hex. However, there's a double bond there. Where? What is the lowest carbon that contains that double bond? Carbon 1. So 1 in, double bond in. So 4 bromo, 2 ethyl, 5 fluoro, hex 1 in. Yeah, done.